recording has started. I will present my screen. My screen is visible.
Yes,
Okay, good. Okay, so week 10 basically it starts that till week 9. What we have seen that we have focused basically uh, for the search in the state space and in the solution space,
yes,
and we also saw the problem decomposition and seen the goals to sub goals. For example, in the AO star, we saw, then we also saw in the means ends analysis that we decompose the problem into the smaller problems and then we solved it. So basic idea now is that till now we have been seeing a function called moveGen function, and in the moveGen function it was given to us that this moveGen will produce this. But how does this moveGen function works? How to do automatically? So we will dwell now into something called the patterns in the state. That there are certain patterns, and identifying those patterns, then the state changes. So that is the basic idea of this. So this is known as the pattern directed inference systems. That we see a pattern in a state, and based on that pattern, some action takes place, and then a new state is formed. So for that, okay, there are certain rules we make that this rule is for this pattern, this rule is for this pattern, and this will get activated. So this is the basic intuition behind the pattern directed inference systems. And then the professor he covered okay, the declarative programming. So aspects of the declarative programming, we know it was covered during PDSA also, that the difference between imperative and declarative is that in the imperative the programmer gives the steps how to solve it. Whereas in the declarative programming, we say that what do we want? What is the end state we want? What is the initial state? What is the end state? And we also associate some rule with that pattern in the state. And these rules are also known as productions. So I will not go through that in detail. So in the rule-based production systems, there are three main components. One is called the working memory. So working memory is also known as the short-term memory of the problem solver. It contains basically the current state, and all the patterns which are inside the working memory, they are known as the working memory elements. So there might be lots of patterns in the working memory elements, working memory. The second component is the rule, and rule is also known as the production. It represents a move, and it has a name. It starts with P, then it has a name or identifier, and it has got a something like LHS, then arrow, and then RHS. The LHS means that it contains some patterns, and once those patterns are identified in the working memory, in some working memory element, so then on that working memory element, that action takes place, which is given in the RHS. For understanding the rule or the production, it represents the long-term memory because it does not change in the problem solver. It remains same. Whereas based on the outcome of this action which has taken place in the RHS, the working memory element might change. So that is the reason we call working memory as the short-term memory and the rule as a long-term memory. Now, these are the two things, and we can say that working memory is like data, and the rule or production is like a rule. Now, the third is the executioner, which is the inference engine. The inference engine is responsible to match first the rule with the working memory element, number one. So after matching, there might be some, okay, for example, 10 rules, and there might be in the state there might be some 1,000 patterns. So these 10 rules, they might match, okay, for example, with some 30 patterns. So after matching, a conflict set is produced. The conflict set contains basically the rule name and the patterns with which it has identified. So like I gave the example that there are 10 rules and there are some 30 patterns it has matched. So for example, we have got some 50 elements in the conflict state. But in every cycle, only one rule will fire. So the inference engine, the second part is the resolution, resolve. Resolve means that how to identify that entity in the conflict set which will be actioned first. So for that, there are various strategies that I will cover later. So that second part is the resolve, and third part is execute. Now, once you execute, there may be a change in the working memory. And when you execute, there are certain actions like make. When you make a new working memory element, you can also remove, you can modify. Modify uh, means basically you are deleting one element and then you are adding one element. Then there is halt, then there is read, write, print, some other things. So if we see from top, any rule based production system, it will have working memory which is akin to data. It represents the short term memory. It contains working memory elements. Working memory elements are nothing but they are the patterns with the class name. The second component is the rule. Rule means it has got a nomenclature LHS to the RHS. LHS contains the patterns which have to be identified. RHS represents the actions which are to be taken. The rules they represent the long term memory. And the third component is the inference engine. Inference engine does three things. It matches the rules with the patterns, and it produces something called conflict set. The second part is resolve. Resolve means to pick up one entity from the conflict set which is to be executed in that cycle. The third is execute. Execute has got various things. It can modify, it can make, it can remove, it can read, it can write, it can halt, and some additional things. So this is the basic top view of any rule-based production system. So here I have covered in detail, for example, this inference engine matches, resolves, repeat. Inference engine looks like this. When it matches, so it is taking the patterns from the working memory, it is checking the rules, and it matches. So if we see a rudimentary view or the brute force view, then we can think that in every cycle, because the working memory is changing, so in every cycle we have to carry out that match. So it will be computationally heavy, it will be time consuming. So I'm taking basically the concept towards the retinette, that how we can avoid that. But before that, like I have covered, that there is a match, there is resolve, there is execute, and we keep on repeating till some termination criteria. So the match algorithm takes the set of generate the conflict set. Each element in the conflict set is a rule along with the identities of the WMEs. The second part is resolve. So in the resolve, there are certain strategies which has the professor has covered later, but I'll cover here only. The resolve, it can have, for example, something called laxity. Laxity means the most recent. Laxity means the lexicon order. So whichever is the recent pattern which is there, we'll act on that first. So we might have that strategy. The second strategy might be specificity. Specificity means that the rule which has got more number of patterns, basically it is more specific. So that might be the strategy that okay, we will act on that rule first. The third is something called refractoriness. Refractoriness means that once a rule has been fired, then it should not be fired again. Otherwise, it will keep on firing. So refractoriness essentially means once a rule has been fired or executed, it can't be fired again. And the inference engine execute, I have covered. It has got actions, certain actions like make, delete, modify, print, halt, read, write, load. So now we come to one of this kind of system which we said a rule-based production system. So one of the rule-based production system is known as OPS5. OPS5 is a production system language, and it was originated in CMU in 1978 by Charles Forgy. And OPS5 Some people they say it stands for official production language, and it has been the first rule-based language, and it is more than a search-based problem solver. It is a declarative programming language, and it is also a Turing complete language. So the rule is written like in this brackets. It has got P. P signifies that it is a rule. Then rule has got a rule name. Then it has got LHS, some patterns. Then an arrow, and then RHS. Then what are the expert systems? Expert systems are the programs with knowledge acquired from domain experts, and this knowledge is converted in form of rules. For example, there was a language written R1 for configuring VEX computer systems. So the syntax of OPS5 remains the same. It has got a working memory, it has got a rule, and then it has got the inference engine. So I will not repeat it again. But here, for example, this is an example of a pattern. So pattern has always a working memory element. Sorry, working memory element has always a class name. This is, for example, here it is a student. Then this hat signifies that it is a attribute. So there is an attribute called name, and this is the value Sudhir. Second attribute age, value 20. Attribute semester 3. So this is an example. So point to be noted here that WME is enclosed in these brackets and has class name. It has got attributes with hat and the values. The values, if there is nothing specified, the default value is nil. So that we have to remember. And all the WMEs, they are indexed by the timestamp. So indicating the order in which they were added to the working memory. So it will have 1, 2, 3, 4, 5, 6. So it signifies in which order they were added to the working memory. Till now, everything is clear. If any confusion is there, I can repeat again.
No, everything's clear.
Yeah, good. Okay. So we go ahead again with this. So we have understood working memory. We have understood working memory element. Working memory element is basically enclosed in these brackets. It has got a class name. It has got attributes. Attributes are identified by the hat, and then it has got values. If there is no value, then the default is nil, and they are timestamp. So these are the examples. Then we come to rules. So rules I earlier also covered. Rules are always identified with P. P means production. Then it has got a rule name. Then it has got a left-hand side LHS. LHS are the set of patterns that conform to the syntax of the WMEs. The value field in the patterns can have variables and the Boolean tests, and there also maybe even be negative patterns also in the LHS. Example is here. P means it is a rule. Ranking, this is the rule name. Then these are the patterns. Next, attribute rank, and these two, if it is enclosed in this less than and greater than, then it means this is a variable. So it means this is a pattern 1 with class name next, with attribute rank, and with any variable r. Second is the pattern 2. The class name is total marks with the attribute student, variable s, second attribute marks, variable m, then attribute rank, and rank is nil. And this third is an example of negative, like we covered here, that in the rule we can have negative patterns also. So this is a negative pattern here, that total marks greater than m, rank nil, and negative means that this pattern should not be included. So when we say a rule like this, so it means pattern 1 should be true, pattern 2 should be true, and pattern 3, this is a negative, so it should not be true. And here we can see this is a boolean, that the attribute marks which are there, it should not be greater than m. So this is an example, and on based, if it matches with some WME, then some action will take place. So we can see that this rule which has been written, that if the next rank to be assigned is R, that next rank R, the second pattern is that if there is a student with marks n and rank nil, so total marks student this, and the third is negative and there is no student with higher marks and rank nil, then take some action. So already covered that in the LHS we can have variables and we can have Boolean tests, and these are the Boolean tests we can have, like for the equality, equal to sign means same type and equal to, and this less than and greater are normal Boolean expressions, and this is something unique here, that less than equal to then greater than, it is only signifies that same type, and it is not equal to, it is only same type. For the integer or floating points we can have less than equal to, greater than equal to. This is important to remember, conjunctions and disjunctions. So conjunctions means that all conditions inside have to be true, and conjunctions are always enclosed in the curly brackets. So if we see this curly bracket, then it means both the conditions they should be true, greater than 3 and less than 3.5. That is the meaning of this. Disjunction is enclosed between 2 less than and 2 greater than, and it means or condition, that any condition which is true, then that RHS will take place. So here in this example, Monday, Wednesday, or Friday, it means Monday or Wednesday or Friday. So important thing to remember here, curly bracket and these two less than out and two greater than. Now coming to the RHS are the set of actions which can be make a new WME, remove an existing WME, modify essentially means remove and make, and other actions like read, print, write, load, halt. So this is an example of one rule where the RHS is also there. So these are the patterns which are there, the same pattern which was discussed earlier. And now the RHS that modify one. One means pattern number one. This is the identifier for the WME. We identify do this, and modify two is the WME two. Oh, sorry, for pattern two. And here all the actions they happen concurrently. The order is not important. This modify 2 and modify 1, they are happening concurrently. So the order here, it does not have any meaning. So here professor gave one another example of sorting. You can go through that. It is easy. Here he gave an example of match and conflict set. So if we see here, I will request all of you to, you can open the lecture, that PPT which is there, and just devote around 2 minutes to see that these are the rules and this is the working memory. These are the 10 working memory elements, and try to identify which rule is matching with which WME. So I will request you to just take 2 to 3 minutes and to learn on your own, please. Is it all right,
This,
Bimlesh?
yeah, it's all right. Which slide number should we go to?
Okay, I will just check here which is the slide number.
Yeah.
Please, could you share this document also so that it will be friends like while you are teaching?
Uh, can you come again, please?
Ah, could you share this notes document, notes what you have taken,
Yes,
so
yes,
that while
yes.
teaching,
Yeah, I will
yeah,
do that. Yeah, I will do that. But
yeah.
before that, I will just share the slide number.
Is it the
Okay.
wands and domes?
No, no, no. This is different.
Working memory elements, slide 51.
Yeah, just I'm checking.
Yeah.
Okay, what you can do, you can go to slide number 36.
36.
Yeah, and there is another one also. I'm trying to put this right.
22, I guess.
Yeah, 22. Yes, yes. 22 is the one.
Hmm.
Here, okay, now just without seeing the answer on your own, just try to match okay, these rules with the working memory elements. And then you'll get okay, the idea and the drift okay, how to solve it.
Okay.
So here we can see, chalo, okay, I will cover okay, here only. So for the swap sort, he has given two conditions. First condition is array index I, value is x. So this pattern one which is there, it will match with all 1, 2, 3, 4.
Yes.
Okay. And now one by one, if we take for example pattern one, and then pattern one, we have taken for example WME1, that index is
Yes.
1 and value is 7. So the second
Yes.
pattern now we take one by one this index j. So we see index 2 value is 9, but 9 is not less than 7. So here it does not fulfill this criteria. Then we go to 3. 3 is greater than 1. Yes, it fulfills. And 3 is less than 7. So 1 has matched a case. So from here we get swap sort 1 and 3. So it has matched a case. Then we
Yes.
then we take with 4. So 4 index 4 is less than 1, greater than 1, true. Y is less than X, no. So 1 and 4, they don't match.
Correct.
Now, now what do? We take 2 now. Index 2 and then again we match. So
Okay, so
this
we
is,
go from index 2, we go through all of them again.
yes, yes.
So if
So
we take
this,
index 2, we will compare it with 1 and 3 and 4 and all those, right?
yes, yes. So here, okay, if
Okay.
you see, index 2 is greater than 1, yes, but 9 is not less than 7. So this does not match. Index 2 and 3, oh, sorry, here again, this one again, index itself, it did not match.
Yeah.
And 2 and 3, 3 is greater than 2, yes.
Yes.
Value is less than,
It's
3
less
is less
than,
than 9. So
yes.
it
So
has
it
matched again.
matches. Yes.
Yeah, so it will, we will get swap sort 2, 3. So basically, why
And
I wanted you to devote time here, because if you do here, then the retinet will become, to understand that it will become very easy.
so for here, the extension of the logic, 2 and 4 will also be the swap sort.
Yes, yes, yes.
Okay. Okay. Understood. Got it.
Okay, and then okay, you could come to the next rule. So
Hmm.
next rule, we know that next rule is basically on the pattern next. So next is 5. So it will match only with WME5.
Yes.
Okay, and it has taken next rank R. R, so R will become 2.
Yes.
Okay, so here it will become next rank 2. Now it comes okay, and it will try to identify this second pattern. And the third is a negative pattern that it should not be existing.
Okay.
So here, okay, so we can see next rank 2, total marks student this, marks and rank nil. So it will take all of them, 6, 7, 8, 9, all of them it will take
Hmm.
one by one. And
And now what should not exist?
then it says the marks should not be greater than m. So one, for example, we take Rashmi, but here the condition is nil, so 6 will not be considered. So this pattern does not match. Okay, because
Yes.
here the rank is nil, here the rank is 1. So only 7,
Ah.
8, 9 they match. So we go to 7. So 7 student Eva, marks 79, rank mil, pattern 2 matches. Pattern 3 is total marks are greater than m, should not happen greater than m. So 79 and is not greater than m. So this will match, 7 will match. Okay,
Sorry, what is M here again?
M is the marks which are coming from pattern 1. So pattern 1 we matched okay with what? Total marks student Eva marks 79.
Yes.
So S became Eva, M became
Yes.
79, rank is nil.
Yes. Correct.
And then it says the marks should not be greater than M. So 7 again matches, the marks are not greater
Yeah.
than,
Correct.
okay.
It's equal to.
Yeah, so 5 and 7 they have matched again. Now similarly we come to 5 and 8, it will also match because 79 79 are equal.
Correct.
When we compare 5 and 8, this 69 will not match because 69 is not greater than M. Okay, so basic
Yeah.
idea is that after the match we get a conflict set. So this is an example of conflict set. So these are the rules which are matching, but in this cycle only one rule will fire. So the first action which the inference engine does, it does this matching part. It matches the rules with the working memory elements. It identifies those combinations which can be fired or which can be executed. Suraj, okay, is this clear?
Yes, yes, it's clear.
Okay. Okay.
It's clear.
Yeah, good. So then we come to the, okay. So this we have understood okay, how these rules okay, they matched okay, with this. So what are the things to remember? That conflict set is enclosed within curly brackets, and then it has got a format inside that there is a rule name, and then there are the names of the working memory elements. So for example, it will be rule name WME1, WME2. This is the format of a conflict set. But now to how to resolve that which rule to fire, because in one cycle only one rule will fire. So already I covered okay, the resolution. It can be lexical order. Lexical means the recent one. Specificity, the rule which has got more specific patterns, or the means and analysis, or the refractiness. This I'll request you to just kindly go through that. I have not prepared the notes because I understood their concepts. Now, what we can understand the problem here. So I will start from starting that a rule-based production system has got three components. One is called working memory, the second is the rules, and third is the inference engine. Working memory has got working memory elements, and working memory basically presents represents the data or the existing state which is there, and that's why it is also is represented as a short-term memory. It can be modified by rules. The format we have seen, it will always have the format, the class name, then it has got attributes, and then it will have values. Then we come to rules. Rules, they have got a format. First P means production, means rule. Then it has got a rule name, then LHS, then an arrow, and RHS. LHS is basically the patterns which it matches with the WM in the working memory. And if some working memory element matches with that rule, then the RHS takes place. The third part is the inference engine. Inference engine has got, it does three functions. One matches, so it will match the rules with the WMEs, and then it will produce something called conflict set. Conflict set format we have seen. So conflict set will have various number of elements, but only one element can be fired, one combination. So the second part is resolve. How to resolve? So it can be resolved basically depending on the strategy which you want to follow. So the strategy can be the most recent, which is lexical, or the specificity, or the means and analysis, in which okay, we take the first bigger difference, we solve it, then the second bigger difference. And the refractoriness means that once a rule has been fired, it should not fire again. So with all these concepts, we come to retenat, which does all these actions. Retenat, the basic idea of retenat is that if we see a rule based production system, what we can see two problems. One problem is that after in every cycle we have to match again and again, and this might become computationally expensive. So retenat idea was one, that in the first match when we did, so for example 10 rules they matched with 30 working memory elements. So we have got a conflict set. for example, in the conflict set, we have got 40 entities. Now, of these 40 entities, based on some strategy, we fired only one rule. So this rule which we fired, it can either modify some WME, or it can delete, or it can make some WME. So basic idea is that in the conflict set, if we had some 40 entities, the 39 entities which are there, they will remain the same. So why should I match again and again? Have you understood the concept? Anyone? Any doubt?
Yes, I've understood.
Vimlesh?
Can you come again, sir?
Okay. So, like in the starting, we did the match. Okay? Inference engine carried out a match. So there are 10 rules, for example. There are some 100 WMEs, the data records are there. And then it identified that there are 10 rules which are which are matching with some 30 datas that they can function on that. So what we did, we made a conflict set. So conflict set, okay, for example, they have got 40 entities. Now in one cycle, only one rule will fire. One rule will fire means कि out of these 40 entities in the conflict set, only one combination will be actioned. So in the next cycle, why should I start matching again? Because already this 39 combination which are there, already इनका match तो हो गया है. तो मेरा जो नया जो मेरा बना है, either I have made some new WME, I should match only with that.
Okay, so you are again using that WME.
Yeah, so I don't carry out a match or full match again. Okay, so that is one concept of like a main idea behind the written end. How it is implemented, it is a different that. And the second basic idea was that many rules, we have got some patterns. So first pattern, second pattern, some patterns might be common in many rules. Like for example, in rule one we say next and rank are. In the second rule also there is that part. In the third also it is that part. So the second basic intuition behind the written act was that when some rules are having, they have got some common patterns, so why to match again and again in those rules? So can I store those results somewhere and I can use them again and again? Is that clear? Suraj?
Yes, clear.
Okay,
It's clear.
okay, very nice. Okay, so with these two intuitions or the two ideas which are behind written end, so the concept came the tree kind of structure, because the tree kind of structure, it gives us that kind of which can we can implement what I discussed just now. So the written it has got a tree like structure in which it has got a discrimination tree, and then it has got a down here. So it has got two types of nodes. One is called alpha node and second is called beta node. So alpha node is basically it. Alpha nodes serve as the working memory of the rule based system, and alpha nodes have got only single parent. Okay, it cannot have more than one parent. So once a WME is inserted from top, WME is nothing but it is a pattern. When we are inserting from top, so it will flow down to the last possible depth and it will sit there. जहाँ पर भी उसका possible है, it will keep on going. That I will demonstrate with the examples. So the WME is inserted at the root and it is written by plus WME, or second is minus WME. For example, if some rule has been fired and we are deleting some WME, so it will go and will remove that WME which was sitting on that alpha node. So these WMEs, they travel down the discrimination tree. First test usually looks at the class name and the separates the tokens. Subsequent tests look at the values of some attributes. And the key is to sequence this test in such a manner so that the common tests in different patterns are higher up in network and shared between patterns. This is how this tree is built. So, but in our course, they have not asked us to build these trees. They have been given to us in the PAs and GAs. We just have to learn how to put those WMEs in these alpha nodes. And once these alpha nodes are fitted, for example, this here, he has given an example. I'll not go through this because I'll cover the PAs and GAs in detail. The beta nodes are the ones which are in a circular or these shapes, and they test the conditions. Here we get the results. The WMEs they have sit on the alpha nodes. Alpha nodes are in the rectangular formats, and the beta nodes they can have more than one parent also. So here are the those conditions which are matching, and then we get the result. So with this, I will come to the understanding of the ReteNet with a simple example, which professor had covered. So this slide, okay, I will show you. If I request all of you to go through this slide, and then we can discuss. Okay, in case there is some confusion. Okay, this is a slide. Okay, so I'll request all of you just to devote around 2 to 3 minutes on this.
Okay, sure.
One doubt, sir. Uh, Hello. Yeah, Lilith, sir.
Hi, Ashutosh. I can hear you.
Sir, I have one doubt. In this 47 slide, the
Yeah.
cap represents not, is it?
Just hold on. Just hold on.
That cap thing.
The cap represents an attribute.
Okay, it represents the attribute. Okay, attribute.
Hat,
Yes.
hat, 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 hat means attribute.
Okay, okay.
So if we see, for example, first rule, P means it is a rule. Green pyramid, that is the name of the rule. Then it has got four patterns: one, two, three, four. First pattern, block, attribute name, and variable X. So it will take blocks, name, and with any variable one by one, and then it will match. And these 1 2 3 4 means and that all these four patterns have to match. Then only that RHS will take place.
Okay, and in this type of representations, how we explain, or is it like we do that or not?
Okay, so here, okay, Ashutosh, we have seen this thing something like in decision trees.
Okay,
So we take a decision, block name this. Okay, if this is there, yes, then block base block X shape square more than one. And okay, then so it keeps on making a tree. And only one
okay,
branch of that tree is true.
okay. It's more like a tree than
Yeah,
logical things. Okay,
yeah. So
I joined a
that
bit late, sir, so that's why I don't
okay.
have this idea. Yeah,
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 no problem.
got it, sir, got it. Thank you.
Yeah. So if you see in this slide also, it is making a tree. So
Hmm.
one branch of the tree will be, true for one pattern. Then it goes for the second, third. So this retin it makes basically a tree.
Okay,
And based on these conditions, we keep on getting all these.
got it.
The good part is that during the course, they are not asking us to build this tree. We just have to see that once we put okay, some rule, or here he has not given the WMEs, what happens that this tree is given to us, and then WMEs are given to us.
Okay.
Now what we have to do, we have to insert WME one by one, and we have to see where that WME has gone.
Mhm.
Okay, either the WME has to flow to the deepest alpha node. So it can come here, it can come here, or it might get stuck here only, depending on its condition. So that is the basic idea. And if we learn this, then solving the PS and GS is very, very easy. Okay, that's why I am requesting all of you just devote 2 to 3 minutes just to understand slide number 47 and 48.
Okay, okay, sir. Got it.
Yep. I'll just take 2 minutes break. I'll just come. Okay, can we commence now? Hello.
Yes, yes.
Okay.
Yes, we can.
Yeah. Okay. Now, so with this understanding, we'll go to the PAs and GS directly. So here, PA is one. Uh, he has given one example. We have seen the resolve and all that. So PA we can open, and he has given the WMEs, and the net is given to us. And now we have to pick WME one by one, and we have to see where this WME will fit in the net. So for example, WME 124, it is the block means class name, attribute name, value is 1, second attribute is owner, name is Harry. So we come to this tree. So the class name was what? Block. So we come to block.
So
Hello.
yeah, so A4, it will go in A4,
Yes. And
and
A4 now it is coming to name. So it has
yes,
what attribute? Name.
name X. Yeah,
Okay. Now after this name, there is no nothing called owner. Okay.
right.
So all these WMEs which are there, 1, 2, 3, 4, they will come here and sit here.
At A15.
8A15.
Okay.
Is this clear, Dimlesh?
Uh, one second, please.
Sit
So
here
see,
means.
these are the WMEs.
Okay,
The class is block.
okay,
Attributes are name. Second attribute
okay.
is owner.
Hmm,
So when I put WME1, so what it will do? The class name is block. It will come to block.
correct.
Then it come to name. The
Yes,
second attribute owner is not there. So what it will do? It will sit here only.
yes, yes.
Similarly, I insert WME2. It will come here, sit here. Similarly, 3 and 4. So WME
Okay,
1, 2, 3, 4, they sit here.
got it.
Okay. And now from here, what we are getting, basically we have got WME 1, 2, 3, 4. So it can have four names which are there. Name 1, 2, 3, 4. Okay. So they are sitting here. Now we come to, for example, WME5. It says class is base. So
Yes.
what it will do? It will come to base. It has
Base,
come
yes,
here.
A2.
Okay.
Yes.
Now it sees second. It sees
Block.
block one. So he will
Yes.
see here block one. So
A6.
here, okay, A6 it has come. Very good. Then it come to shape circle. So
A10.
here A10. Very good. And then it come to area one. Okay.
Yeah. So A19.
Area is equal to 1. This is A19. So he has come here and he has set here. So I have written
Okay.
5 here. So WME5, where is he sitting? He is sitting here. Okay.
Okay.
Now you see WME6. It is same, but the shape is square and area is 20.
Yeah. So
So
A20.
it comes here, and it comes again here. Area is greater than, and it is a square. So it will come to
Yes.
A21.
Oh, it's a square.
Yes, it is a
Oh,
square.
correct, 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 correct.
Okay.
Okay, A21.
Yeah. So now 7 will sit here, A20. Okay.
Yes.
So similarly, now we come to 9. Side block 1.
Hello.
His internet connection problem. Yeah,
Yeah, possibly.
yeah, let's wait for it.
Yeah.
How did one thing like you were saying A19, A20, right? So that is
Yes.
naming convention that we give, or
I think it
it
will
was
be in
already
the, if you see the PA, it is in
okay.
the table, graph in the tree that they have given already.
Oh, okay, okay. It's will be side. Okay, like questions will
Okay.
be like what will be.
I think the questions will be similar. They won't tell us to make the tree. They will just tell us to place the processes. They will just tell us to place the
Okay,
rules.
like this five WME5 belongs to which like
Yeah, yeah, yeah,
A19 or
yeah. Correct,
A20, like
correct,
that.
correct, correct.
Oh, got it.
Where does it go and halt? Where does it sit?
Mm-hmm. Okay, what is
Only
its
those
paths
type of
or something?
questions. Correct.
Ah, got it, got it.
Hello.
Yes, now you are audible.
Hi. Sorry. My connection got lost. Actually, I'm connected through
Yeah,
my.
yeah, it's okay.
Yeah.
Fine, fine. Audible.
Present again. Okay. It's visible, na? Okay.
Yes, it's visible.
Okay. Abir, okay, now can you see which WMEs will be sitting where? Hi, Abir.
1 second. Yeah. Yes. Yeah, I have the PAs open.
Okay.
So
So we can see the WMEs. What we have to do, whatever the question is there, you immediately what you do, you solve all the WMEs, and you find the place for these WMEs where they are sitting.
yes.
So like I have done here, and I came to know that these are the places. Okay.
Hmm.
Now these are the rules where they are culminating. Rule 1, Rule 2, Rule 3, and Rule 4. And now here you can see that, for example, for Rule 1, which has to fire, Rule 1, one arrow is coming from A23. And which is the WME which is sitting here? 9.
9. Correct.
So with the Rule 1, one combination 9 has come. Along with 9, here 5 has come.
A19. Yeah.
Okay.
Correct.
And then the third is coming from here, the name,
Name. Yes. A15.
A15. So see, A15 is the name, and
Hmm.
5, block 1. So here see, the block has to come which block? 1.
1.
Okay. 5 block 1 and the 9 block 1. So these three conditions they match, these patterns match, the Rule 1 will fire.
Okay.
Okay. So this is how we build the conflict set.
Understood.
Now
But
we
I
see,
have I have a small doubt. What
yeah.
about in A15? What about block 2, block 3, block 4?
See, they have come, and if you see from here, we can make 4 acts. Okay? 1, 2, 3, 4.
Yes.
Okay. So from 1 act is coming here.
Okay.
From block 2, it will go there. It is like that.
Okay. Okay. So each block has its own beta node that is going towards.
Yes.
Okay. Okay. Okay.
So similarly, we can see for this 2 also, we can see for 3 also, and we can see for 4 also.
Okay.
Okay. And we can easily answer now the PAs. Okay. If you open the PAs, you can answer all the questions.
Yes. I just went through the questions.
Yeah.
Yeah.
So can you shortly come to the last part? Last part you said that arrows. I got the A15 thing, A10 thing,
Okay. So
and
see, this is the retinet, and these arrows have been given to us.
that is given these arrows.
Okay.
Yeah,
So now you see for Rule 1, this arrow is coming from here, from A23,
yeah.
which is the WME who's sitting there?
Mm-hmm.
9.
9 9. Yeah,
Okay. So WR1, WME9. Then this arrow who's sitting here? WME5.
5.
And here, this is coming from name, this arrow. Okay. So WME 1, 2, 3, 4, which was there, if we see 5, it is block 1. So it will take WME 1. So for Rule 1 will fire because these three conditions are matching with which WMEs 9, 5, and 1. So conflict set, the first element is R1, 1, 5, 9. Is that clear?
Okay, got it.
Now we see the second entity of the confliction set. Conflict set. R2 will fire for this arrow. Who's sitting
10,
here? 10.
6,
Then here 6. And we
and
can see
second one.
here which is the block. 10 and 6.
It's
10 is
block
block 2,
2.
block 2. So
Block 2.
WME
Block 2.
2. So
Yes.
2, 6, 10. Okay. So the second entity of the conflict set is R2, 2, 6, 10.
Correct.
Now we see the rule 3. Will it fire? So when we see rule 3 in
B1
the
comes from
rule
B1, it comes from
3,
A18.
but 18 somebody is sitting, 11 is sitting, है ना?
Yes, yes.
Yes.
And then it has to come from
A20,
820, 7 is
7.
sitting. Okay,
Yes.
and with that it will take some name also. So we see in 11 and 7 क्या क्या blocks हैं. So
7
11
is
block
block
3.
3. Block 3.
Okay, so it will take WME3.
Yes, so 3, 7, and 11.
Yes, so second third entity वो हो गया हमारा, है ना? Now we
Yes.
see R4. R4 में again
R4,
it is coming from
again it's
7
the
and
same.
11,
Yes.
and it will take the same again from here, WAND.
Okay.
Yeah, but it's the for this it's taking B4. There are two arrows, right?
In which क्या R4?
B4. Yeah, R4, but for
Oh,
B4 there are two arrows.
B2, B3, B4.
Yeah, so two arrows are coming towards it.
Okay, so to fulfill this, now see here 14 is sitting.
Yes,
So it will take 11, it will take 7, it will take 14,
14.
and it will
Correct.
take name from here.
Yes.
Okay. So 14, if you see, it will also be block 3 only.
No, it's
14,
block 2.
14 is block 2.
14
14
is
is block 2.
no, 14 is block 3. In the PA it's written 14 is block 3.
Okay, so then my writing okay, mistake is there, because logically it has to be block 3.
Yeah.
Because 7 is block 3, 11 is block 3, this is block 3, and from here block 3 will come. Okay.
Yeah,
So
and
here,
we do not see. Yeah, correct. So we do not see for B3 as well.
yeah,
B3 is coming from somewhere else also.
yes, B3 is coming from here, 13.
Yes. So for
So 13 was
13,
block 2. Yeah.
no, 13 was block 1.
Surface is spherical.
Yes.
Surface.
And,
So,
113.
yeah.
So 13, right? So block 1,
So,
surface point.
okay, so it means okay, rule 3, which is there, it will not fire because its conditions are not getting met.
Yeah. Correct.
Only rule 1, rule 2, and rule 4.
Hmm.
Okay. Now, in the next question, they are asking that if we go with the specificity, then which rule will fire first? So, in the specificity, we have to see the length of the path.
Okay.
जिसका पाथ ज्यादा लंबा होगा वो ज्यादा स्पेसिफिक है, उसमें ज्यादा कंडीशंस हैं.
Understood.
So that path
So,
will fire.
so which is that path? One,
So we can see here only this path is the longest. 1, 2, 3, 4, 5.
5, 3, 4, 1, 2, 3, 1,
अली
2.
इस लेवल से हम देख सकते हैं यहाँ पर,
Yeah. Correct.
है ना? तो इसमें
Correct.
सबसे बड़ा
Check
पाथ है,
the
तो
Yeah.
R1
alpha
मैंने इसको
nodes for
पकड़
this,
लिया.
right? For
So
specificity,
R1.
we check alpha nodes.
यस, है ना? और अगर क्या रिसेंसी से करेंगे तो कौन का होगा बताइए? रिसेंसी से होगा, देन वी सी द पैटर्न. सो सबसे लास्ट पैटर्न किस में आ रहा है हमारा? R4 में.
R4 में. Okay.
सो रिसेंसी से हमारा R4 होगा.
Okay,
ठीक है
so
ना?
recency comes from the patterns that they have given, which is the last pattern coming in.
Yes.
Okay.
Yes,
Okay.
most recent pattern.
Okay.
Okay. Now, GS ka, you can open the GS.
Okay.
So first 6 questions which are there, they are basically all theoretical. Already we have covered.
Okay.
Already I have covered all these concepts.
Yes.
So refractoriness property means that the same rule data type tuple doesn't fire repeatedly. It will fire only once. Okay, just see this again, and I'll just give me just 2 minutes. I'll just join back.
Yes.
Okay, can we continue?
Yes.
Okay, so these are questions theoretical, these are easy. So 6 is again when WME enters a retinite, it resides at the deepest alpha node on the path that matches the WME, like we have seen that.
Yes.
And it also may reside in several alpha nodes in the retinate. If the
Yes.
they are it is matching on many conditions, then it can go to some other node also.
Yes.
Now this is a very interesting question. Question number 7.
Hmm.
A rule has been given, rule 1, 2, 3, and the WME is given.
Correct.
And now please okay, solve it.
I think I have
Okay.
solved it. I think the reduce rule will fire, and then it will change to 20 minus 15. So it will become A15B5.
Very nice. And then after that, which rule will fire?
A15B5. Uh, A15B5. So swap rule will fire.
Yes, swap rule will fire. So what it will become?
It will change it. So A5B15.
So A5 B15. Now again, which rule will become applicable?
Yeah, wait,
A5
wait. Can you explain this once again? I lost track.
It's a very good question. Okay, so all of us we should do it. Just as a practice. So we'll get hang of it.
So reduce rule will fire again.
Yes, it will fire again. And what will it will become now?
5, 10.
5 and 10. Yes, very nice.
Yes, 5 and 10. And then
Uh,
swap rule will fire
and
again, and then reduce rule will fire.
no, 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 no,
No, no,
no.
no, no,
Swap
no,
rule
no,
will
no,
not
no.
fire.
No, 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 it
Again,
won't
rule
fire
3
again.
will fire. Again, rule 3 will fire. है ना?
Oh, yeah, it's greater than. Correct. It's
Yeah.
greater than. Sure. So then it will become 5, 5.
5, 5. And now when it is 5, 5, again rule 3 will fire.
Yes. And then it
है
will
ना?
become 5, 0.
And then swap rule will
And
fire.
then swap rule will fire.
Yeah. So he has
And
asked
then it
again
will
that how
become
many.
0, 5.
Yeah. So he
Correct.
has asked okay, how many times rule 3 has been fired and how many times swap rule has been fired.
Uh, so swap rule, reduce rule has been fired 4 times.
4 times and swap rule 2 times.
2 times. Yes, 2 times.
Yes. Okay. So that okay, we can see it is a very good
Uh,
example.
like how you say that it is fired or what? Like if it satisfies that condition, then it
Yes.
fires.
Yes,
The
yes.
pattern
So
matches, so then it will
Suraj,
be fire.
Okay.
Suraj.
Yeah.
So you see the first condition which is there, A is 15, B is 20.
Yes.
So we have to see in these three rules which rule is applicable here.
Rule 3 only. Reduce rule. Yeah.
So very nice. So rule 3 when it
Yeah.
fires, so it will, and we know
It
from
will become as
refractiness.
15 and 5. Yeah.
So we get a new record now, A
Yes.
15, B 5.
Yes. Correct.
Now when A is 15 and B is 5, then which is the rule which is applicable now?
Swap rule.
Yeah. So now we will get A,
A as 5.
yes, and B,
15.
very nice. So now we have got A5, B15. So
Yes.
now which rule okay will fire?
Rule 3.
Yes. So Mali, you keep on checking which rule is applicable.
Okay. Got it.
Okay.
And how many times? How? Got it.
Yeah. So how many times which
Understood.
rule has been fired again?
Okay.
Okay.
Oh, yeah. Got it.
Okay. Now similarly, this is also a good question for the practice on the same concept.
Hmm.
These are the two rules which have been given to us. These are the
Yes.
three WMEs which have been given to us. And there is first question, how many classes are there in the rules given?
Uh, 1 class.
Yeah. And name of the class?
Rec.
Yes. So that is pretty easy. The second question, what will be the conflict set?
Okay. So the conflict set will be index 3 value 17. So once I remove this thing,
So what do we do here? The trick is like that. We take one by one.
Hmm.
Okay. So we take
Yes.
first index, for example, for the rule one, we take index A. Index A means second we take WME1. So index
Yes.
will become 3 and the value becomes 17.
Yes.
Okay. And then we start comparing it with the 202 and 203 and check which conditions which is matching.
Yes.
So for index A, this condition will not match for anybody. So index 3 will not come here.
Yes.
है ना? So then we come to then we take 202 here. So 202 mein index becomes 2. So only the
Correct.
3 will match. Only 3 will match here.
Yes.
And then we check
202 index
value
becomes
of
1.
and value 17 is less than 20.
20.
Yes, it is
Correct.
true. तो हमारा मैच हो गया रूल 1, 202 एंड
2
201.
201.
यस 202 201 एक मैच हो गया हमारा.
Yes.
नाउ वी टेक फॉर एग्जांपल इंडेक्स 1 हमारा मैच हो गया था, इंडेक्स 2 के साथ मैच हुआ. नाउ वी टेक 203. 203 में
Yes.
इंडेक्स बिकम्स 2, वैल्यू इज 23.
Yes.
Now we take index 3. Is index 3 greater than this 2? Yes, it is matching.
Yes, it is
Value 17 is less than 23, matching. So next
matching.
becomes 2. So 201 203.
Correct.
तो यहाँ से ये वाले मिल गया हमें, ये वाला रूल
And
1
rule 2 will rule 2 will only be 201, right?
रूल 2 is 201. Yes,
Okay.
बिल्कुल. So we have got conflict set क्या मिल गया हमें,
Conflict set.
है ना? रूल 1 201 202, रूल 1 201 203 and रूल 1 201. So this is the conflict set. So first question is which WMA occurs in multiple rule data tuples. So 201 201 201.
201 201.
Yeah. Then this is the example. This is the question. This I will not solve it, and this we have understood the concept. So what you do, you keep on putting the WMEs.
Hmm.
Okay. So you'll fit the WMEs and you'll get the answers.
Yes. Yeah, so we just have to put the WMEs and then they have directly asked WME
Then you
301,
just
where
ask.
is it?
Yeah.
Yeah. Okay.
So in the question paper also, so basically there will be 3-4 questions, So what you do, you put all the WMEs.
Hmm.
It will take just precisely less than a minute if you do that, and you'll know which WME is sitting where.
Correct.
Okay. So this I will leave it up to you, okay? So with this,
Sure.
I think we have finished. I will anything to clarify, Suraj?
No, no, it was clear. A nice session again, once again.
Yeah. Hi, Bhavya. Any additional input?
No, not as such.
Yeah. Ashutosh?
Thank you, sir. It's been a good session.
Yeah. Thank you so much for all of you. So Abhi, we'll call it off. Okay, I'll stop recording.
Yeah, sure. Please do share the PDF and the recording.